Why is there always the same amount of water on Earth? Water, clear, inconspicuous, omnipresent. Without it, there would be no life as we know it. It is a huge part of our world. It fills oceans, rivers, glaciers, and the atmosphere. It accompanies us every second, in our breath, in our food, in our own blood. But have you ever wondered about something truly amazing? Despite the passage of billions of years, dramatic climate changes, natural disasters, and human activity, the amount of water on Earth remains almost unchanged. Not less, not more. How is this possible? Does Earth have some hidden mechanism for protecting this extraordinary resource? Or does the answer lie in the cosmic history of our solar system? Some scientists even speak of a miracle, a perfect balance that the planet has maintained since the first oceans flowed across its surface. In today's episode of Unknown Tales Files, we take a closer look at this extraordinary mystery. We go back to the birth of our planet, follow the journey of a single drop of water through the atmosphere and oceans, see if water can really disappear into space, and compare our Earth to other worlds that can only dream of water. Prepare for a journey that will change your perspective on every sip of water and every rainy day. Because water, although everyday and ordinary, hides a much bigger story than you might think. Part 1. The Birth of Water, a Cosmic Journey to a Young Earth. 4.5 billion years ago, the young Earth was a place of chaos and constant bombardment. Amidst red-hot magma, toxic gases and dust, the seeds of our planet were forming. But where did the water that now covers over 70% of its surface come from? One of the most commonly accepted theories is that water was already present in the materials that formed the Earth. In the distant corners of the galaxy, in so-called molecular clouds, hydrogen and oxygen combine to form water molecules, freezing on the surface of cosmic dust grains. These grains, sticking together into larger blocks, eventually formed our planet. Another theory is that water-rich comets and asteroids struck the young Earth over millions of years. Each impact could have delivered small amounts of ice that melted in the heat and fed the primitive oceans. There are also hypotheses that volcanic processes played a huge role. The Earth's interior was filled with water vapor, trapped in minerals. As a result of intense volcanic activity, this vapor was released into the atmosphere, from where it eventually condensed as rain. Either way, the birth of water on Earth was not the work of a single event. Rather, it was a long history of cosmic journeys, collisions, and constant transformations that led to the creation of the ocean of life in which we exist today. Part 2. The hydrological cycle, the infinite journey of one drop. Imagine a single drop of water. It falls as rain on a leaf in the Amazon jungle, evaporates in the heat, rises into the sky, and then returns as a snowflake on the Himalayan peak. This endless dance of water has been going on for hundreds of millions of years. The water cycle is nature's most magnificent mechanism. It begins with evaporation, when the sun's rays heat the surface of oceans, lakes, and rivers. Water molecules turn into steam and rise into the atmosphere. There, in cooler layers, the water vapor condenses, forming clouds. From the clouds, water returns to the surface as rain, snow, hail, or fog. It ends up in rivers, lakes, seas, or soaks into the soil, replenishing underground water supplies. Some of this water evaporates again, and some travels through rivers to the oceans, where the cycle begins again. Water does not perish in this process. It does not disappear, nor does it magically appear. It moves, changes state, circulates endlessly. Thanks to this circulation, the same water we drink today could once have fallen on the head of a dinosaur or frozen in an ancient glacier. It is a closed system of extraordinary precision. Without the water cycle, life on Earth could not exist, and despite its complexity, the whole thing takes place in harmony, the result of which is a constant amount of water on our planet. Part 3. Can water disappear into space? Although the water cycle on Earth seems eternal, in reality, our planet is not completely isolated from space. There is a process by which small amounts of water can leave the atmosphere forever. In the upper atmosphere, at an altitude of several hundred kilometers above the surface, water molecules are broken down by intense ultraviolet radiation. As a result of this process, hydrogen is separated from oxygen. The light hydrogen atoms, almost weightless on a planetary scale, can then escape into space. This slow but steady leak of hydrogen is well documented. It is estimated that over 100 million years, the Earth loses only a tiny fraction of its water supply. This amount is so small that it does not significantly affect the global water balance. In addition, Earth's magnetic field plays a key role in protecting the atmosphere. Without this invisible armor, solar winds could easily blow gas and water molecules into space. Mars, which lost its magnetic field billions of years ago, is an example of how a planet can gradually lose its atmosphere and water. Fortunately for us, the Earth preserves almost all of its water wealth. The losses are so minimal that they are practically unnoticeable for everyday life. Part 4. New water. Is space providing us with fresh resources? Although the Earth loses small amounts of hydrogen, the reverse process also occurs: the supply of new water molecules from space. However, this is as subtle as the loss of hydrogen, and its impact on the total water supply of our planet is almost imperceptible. Every day, micrometeorites fall to Earth, tiny fragments of rock and cosmic dust that often contain hydrogen and oxygen compounds. As a result of their combustion in the atmosphere, water molecules can be created. It is estimated that about 10,000 tons of microscopic material fall to Earth each year. However, the amount of newly created water is extremely small compared to the ocean resources. Another source is a chemical reaction between atmospheric oxygen and hydrogen reaching us from the solar wind. In favorable conditions, trace amounts of water molecules can be formed. This phenomenon was discovered relatively recently, but its significance for the Earth's water balance is marginal. It is also worth mentioning the hypothetical transfers of ice from comets and asteroids in the distant past. Although such collisions are extremely rare today, billions of years ago they may have played a major role in building the primordial oceans. Today, however, such deliveries are very rare indeed. In summary, Earth may receive small, symbolic amounts of new water from space, but these are so small that they do not, in practice, change the grand water balance of our planet. Part 5. Cataclysms and water shifts, Earth in motion. Earth is a dynamic planet whose surface is constantly changing. Continents drift, mountains grow, and oceans form and disappear. In this endless geological game, water plays the role not only of a passive observer but of an active participant. Earthquakes can move huge masses of water in a very short time. For example, large tectonic shocks, such as the Indian Ocean earthquake of 2004, not only triggered a powerful tsunami, but also slightly changed the shape of the seabed and the distribution of water masses. Volcanic eruptions also play an important role. Undersea eruptions can create new islands by changing local water circulation, while powerful explosions on land can spew huge amounts of water vapor into the atmosphere, temporarily changing rainfall patterns across entire continents. Another interesting phenomenon is isostasy, the slow rise of land after glaciers have retreated. When huge masses of ice melt, the relieved crust slowly rises, which affects the shape of coastlines and the distribution of seas. Even geographic pole shifts throughout Earth's history have affected the global distribution of water, changing ocean flows and rainfall patterns. Despite these dramatic changes, the total amount of water remains constant. We only change its distribution. Where there is a desert today, there may be a lake tomorrow, and where the ocean roars today, new land may one day grow. Part 6. Water in the Solar System, Reflections of an Earthly Miracle. While Earth may seem unique, water in the solar system is not as rare as you might think. In fact, traces of water, ice, and vapor have been found on many other celestial bodies, although never on the scale and form that we find on our planet. Mars, Earth's neighbor, has huge polar ice caps, mostly frozen carbon dioxide and water. Mars may have had flowing rivers and lakes in the past, as evidenced by vast valleys and dry riverbeds. However, due to the loss of atmosphere, most of the Martian water has frozen or is buried beneath the surface. One of the most fascinating places is Europa, a moon of Jupiter covered in a thick layer of ice. Underneath this icy armor, scientists suspect the existence of entire oceans of liquid water, heated by the heat of the moon's interior. Similar suspicions apply to Enceladus, one of Saturn's moons, which spews fountains of water vapor from its interior into space. The discovery of these geysers confirmed that there is a hidden ocean deep beneath the surface. Signs of water ice have also been found on Pluto, and some of the moons of Neptune and Uranus may harbor frozen oceans beneath their surfaces. However, only on Earth does water exist in three states of matter: liquid, solid, and gas, and in proportions that allow life to arise and develop. This extraordinary balance makes our planet a truly unique place. Part 7. Human influence. Balance on the edge. Water on Earth does not magically disappear or appear, but human activity can dramatically change its distribution and availability. As civilization has developed, it has learned to tame rivers, build dams, irrigate deserts, and drain swamps. Each of these interventions has its price. The construction of large reservoirs, such as the Three Gorges Dam in China, is changing local and regional water cycles. Floods that were once a natural part of the cycle are stopped, and the water stored in artificial reservoirs is changing the local climate and biodiversity. Excessive pumping of groundwater leads to land subsidence, as is the case in the California Valley, where the ground level in some places has dropped by a dozen or so meters. In many regions of the world, excessive exploitation of rivers and lakes causes them to dry up. A classic example is the Aral Sea, which almost completely disappeared from the face of the map in a few decades. Climate change is further disrupting natural precipitation patterns. Droughts and floods are becoming more extreme, and melting glaciers are providing temporary excess water that could lead to shortages in the future. Man neither increases nor decreases the total amount of water on the planet. He shifts it, locks it in reservoirs, changes its course, often in ways that may prove irreversible in the long run. Whether this great natural mechanism survives for generations to come depends on our responsibility. Part 8. Guardians of Eternal Circulation. The water that flows down a mountain stream today may have once evaporated from a prehistoric ocean or fed ancient tropical forests. Every molecule carries with it the history of billions of years of uninterrupted circulation. Our planet, despite its turbulent history and constant changes, has retained almost the same amount of water since its birth. Neither massive earthquakes nor meteorite impacts, nor supervolcano eruptions have been able to disrupt this delicate balance. However, modernity poses new challenges. Although the amount of water does not change significantly, its availability and quality increasingly leave much to be desired. We, humans, have become the guardians of this great natural cycle. Our decisions determine whether future generations will also be able to benefit from the gift that the Earth has been preserving for billions of years. Can we respect the cycle of which we are a part? Will we maintain the invisible, precious balance that makes life possible? Or will we become the generation that disrupts the mechanism that has been operating since the first raindrops fell on the heated surface of the young planet? What do you think? Let me know in the comments. Subscribe if you want, and see you in the next episode.